Hello and welcome back to Danger's Workshop. You are live and uncensored with Robert Danger Bird, CEO, inventor, mountain climber, and magician. Today we will be building an OxiKit in its entirety. If you follow along with me, you will have a completely functional oxygen concentrator at the end of this video. So grab your tools, roll up your sleeves, and let's build an OxiKit. Okay, so I'm going to take a minute to go over the bill of materials and show you what we've got on the bench here. These are all the pieces that we're going to need to assemble the OxiKit. So we'll start here on the far left. So this is not actually part of the machine, but it is a component that we will need in order to create the cooling coils. We're going to take this 3/8 inch OD copper tubing and we're going to bend it around the outside of this 4-inch PVC to create the cooling coil. Here we have the PTFE tubing, which we'll use for the majority of the plumbing. We have the CAT 2 horsepower compressor here. Also, you're going to need a power cord. It does not come with one. It does come with the capacitor and the feet, which we've already attached. Additionally, you're going to need some bolts and some nuts, actually, and some washers to secure the motor to the frame. And those are on the bill of materials as well. Of course, some pipe thread tape, some stainless steel wire. We're going to use this to secure a variety of connections to make sure they don't come off like we did here on these orifices. So you can have your orifices, of course. This is simply a filter. We'll use this at the final stage to make sure that we're not getting any particulates into the output airflow. We've got our pressure gauges, and these are low pressure gauges. They max out at 60 pounds, which is fine. Our sieve pressure is 30 pounds. That's the maximum pressure that we'll really be working with. Here we've got a low pressure regulator. This one operates from 0 to 30 psi. It also comes with a little gauge as well that goes up to 30 psi in the bracket, of course. Here we have the brain with the valves pre-wired and attached. And then we have a variety of tie wraps in different lengths. You need a minimum of 18-inch tie wraps to secure the sieves. And then we've also got some screw-down tie wraps for just securing wires and cables. And then this tie wrap is for securing the capacitor on the motor, which we'll be doing that today as well. Moving down, we have the surge tank. And you'll see the surge tank video in the list on OxiKit.com, as well as the sieves. And there's also a separate video tutorial on how to build the sieves. You can also purchase pre-assembled sieves and surge tanks on OxiKit.com. So that's another option for you if you're not ready to tackle that. Building the sieves is definitely the most complicated part of the process. Over here we have a variety of components. We have the bubbler, which we will use to add humidity into the air. That makes it more comfortable to breathe so it doesn't dry out your lungs. We have the oxygen mask, and it's just a standard medical type connection which slips right on the output of the bubbler. We've got a handle, and you can use any kind of handle you like, and then we've got some wheels. These are 2-inch wheels. One thing when you're selecting your wheels, you want the wheels to sit flat. That way when you rock the machine up, so we're going to bolt this to the back of the frame, when you rock the machine up, you want it to lift the frame off of the ground. So if these tabs are too long, then you're going to have to rock back much further to get the machine off of the ground. So just consider that when you're selecting your wheels. We've got screws for securing the brackets and the wheels here. And I'm just going to use these square drive type screws here. And then we've also got some washers and some additional screws that we're going to use to secure these T's, which will support the gauges. And you'll see when we go through that process how that works. And then these screws are going to be used to secure the rails on the brain, as well as a couple other components like the pressure regulator. Here we have the flow meter, and we have this particular flow meter works very well. There's one flow meter that we found that we had trouble with, and we've notated that on the bill of materials. You want to stay away from that one. And then we have our cooling fans. These are 110 volts AC cooling fans. And then we also have the bolts for bolting the cooling fans to the fan deck. And then over here we have all of the various air connectors. And I won't go through those individually, except in a few notable cases. These are the 1/2-inch to 1/4-inch adapters called Bushings, and we'll use these to connect the air output. The compressor has 2 outputs, so we'll be capping one of those off. And then these we'll use to connect the gauges. So these are just 1/4 inch female couplers. And so that's will allow us to adapt the gauges into the system. And then we're going to use this 90 here to turn the output of the compressor upwards. And then this compression fitting will be used on the end of the coil to connect our cooling coil directly to the compressor. And that, aside from the frame, of course, is everything you'll need to complete your OxiKit. Almost forgot about these. They are 7/8 inch cup hooks and will be used to hold the mask or cannula, if that's your choice, as well as give you a place to coil the power cords when not in use. These are 7/8 inch cup hooks. I would actually prefer 1 1/4 to 1 1/2 inch cup hooks. You'll also need a couple of hose clamps to secure the cooling coil to the fan deck. I like these rubber coated ones, but you could use anything that fits snugly. And here is the complete set of tools that I will use to assemble the OxiKit. Actually, I've already assembled the OxiKit with these tools. I hopped in my video time machine, went forwards after I had completed the machine. Wait, we're not there yet. And as I used each tool, I set it aside so I could produce this complete list for you right now. So let's talk about them. If you're going to solder the power cord and starting cap, you'll need a soldering iron solder and heat shrink. Otherwise, you can use electrical tape and wire nuts. I have a regular drill here and an assortment of drill bits. As I recall, this is a 1/8, 5/32, a 9/32, a 13/32, and a 1/2 inch. And I will call those out as they're being used. And then a 1 inch Forstner bit. This was used to create a pocket on the underside of the lower deck to allow you to put nuts on the mounting studs for the compressor. I used gloves to protect my hands when I was heating the PTFE tubing. Hose clamps were used in a couple of different sections. And then I used a small or a short square drive and a long square drive, as well as a pencil and Sharpie, a standard ruler, screwdriver, crescent wrenches, small pair of pliers. I use those for twisting the wires. A wrench, 5/16 in this case. These are the tools that I use to secure the fan screws. And depending on the type of screws you use, you may use different tools there. Some plumber's tape to seal your connections, and a tubing cutter to cut the copper coil. And here we have a heat gun, which was used to heat up the PTFE tubing to make it easier to slip over the larger barbs. Alternatively, you could use a torch. Just be careful that you don't overheat the tubing. And here we have a tubing cutter. This is optional, but it does make cutting the tubing ever so much easier. Alternatively, you could use a razor knife. I use this to start the holes for the cup hooks. And then wire strippers, nippers, and that is the complete list. And you're also going to need a socket wrench to tighten the nuts on the motor mounts to secure it to the lower deck. Whatever size nut you're using is the size socket you will, of course, require. So we're prepping the motor. It comes in this state without a power cord, so you'll need one of those. The cap for the starting capacitor is also unattached, so you'll need to attach that. And then the feet, which I've already attached, will be loose, and you just thread those onto the bottom. And There's a couple of options on ways to connect these wires. You could connect them using a standard twist wire connector. I'm actually going to solder the wires on, but that certainly is an option if you don't have access to soldering iron, and I'll actually show you that. So let's just get right in. So this is just an old PC power cord that I'm repurposing, and I'm going to trim it to 6 feet. And I'm going to strip these back. And then I'm going to put the cap right here. I'm going to secure it with this tie wrap. I'm actually going to shorten this a little because I don't want it as long as it is. Does it need to be that long? Scoring this outer layer. I don't want to cut into the inside wires. And this is a non-polarized capacitor, so it doesn't matter what the orientation is. So I'm going to take some heat shrink. You can also use electrical tape here. I prefer heat shrink. I'm going to cut a couple of lengths. Actually, I think I may go with a slightly smaller size. I'm going to slip those over. And slip those over. And so I'm going to solder these. Now you could use these wire connectors like this and just twist them on, right? That's all there's to it. I'm going to solder it. It makes a more reliable connection. I won't have to worry about it getting pulled loose. So that's how I'm going to do it. So you can do it based on the tools you have at your disposal. So I'm twisting those wires. I'm going to trim this part here off. If you're not familiar with soldering, there are tons of good videos on the correct way to solder. All right, that's one. However, this little twist here is definitely the way you want to join wires when you're soldering. It makes a rock solid connection. See how I have those twisted around each other? And once you apply the solder, that joint is stronger than the original wire. So we'll give that a minute to cool. We're going to slide this one down. And then the heat shrink, we slide that into place. And then we just heat that. And it will seal and protect that connection. All right, so that's our motor cap. Okay, so we're going to look at a couple of different options of attaching the wires. I've got my power cord, which I've already trimmed to 6 feet. I've already stripped back the cable here. Just give it a couple inches. I've done the same thing on the compressor side. And you'll notice something here. We've got different color wires. So these are the universal wire colors for hot, neutral, and ground. This is not a universal color, but these are ground, hot, and neutral. If you're not sure, then you can use a volt-ohm meter to test continuity between them, or you can just get another cord that uses the classic color codes so you don't get confused. But in this case, I've tested this one so I know which lug goes to which wire, and I'm going to connect it appropriately. So with that in mind, one option is to simply twist the wires together and then use a twist connector just like that. And so if we're going to do it that way, that's all we would need to do is just connect and twist. And then you would want to go much tighter if you were actually going to use that method. And then you would want to tape these together very firmly and completely tape these caps in as well. And just go over the whole thing and make it a nice tight bundle there where there's no way anything could come loose. And so you ended up with something like that. That looks hideous, and I'm not going to do it that way. So I'm going to undo that. So I'm not going to do it like that. I'm going to straight twist them like I did earlier. And I'm going to use a couple of different sizes of heat shrink. I'm going to use this one. Slide it down over that. And then I'm going to take these pieces. I need to shorten those. Those are a bit too long. Let's see. I have pre-cut pieces. I'll need to shorten some. All right, I'm going to make these a little bit longer to give me more to twist with. We're going to use that same method of joining that we did earlier. I'm going to go ahead and solder that one before I neaten up the others. And that's a good joint. You want to be aware that these need to stay slid back, because if you get them too close, then these will start to shrink and you'll have a bear of a time getting them connected, or getting them slipped over the connection to secure it. So now I'm going to clean up this one. Remember to be careful, because you've got a hot solder joint right there and it will burn you. That soldering iron is 750 degrees. That joint is getting to that temperature. One more. So that's cool. Let's slide that shrink over there. Slide that shrink over. And slide that shrink over. All right, so that's a good solid connection. Those wires are not coming off. And we're going to take this piece of heat shrink, slide it over the entire assembly. So we have a nice connection that's never coming off. now we've got these bushings we need to install. And these will go on the output ports. So we're going to put some thread tape on these bushings. And these will leak without the thread tape. And there are 2 output ports on the motor. We only need 1 of them. So we're going to pull it off. So that's what this is for. And this one is the one we'll actually make our air connection to feed the machine. And to turn it up 90 degrees. And we're going to connect this one here. And the plug will go here. All right, so we've got some adjustable wrenches. These are metric. And you don't need to go too tight, just nice and snug. We'll be leak testing later, so if there is a leak, we'll see it and we can tighten accordingly. And then I want to point this in that direction. All right, so the next thing we need to do is we need to make a template for these screw holes. So we need to know where to drill holes for these 4 legs. Okay, so we're going to make a template, and all we need is a piece of paper and a pencil and some extra hands. All right, so it's important not to let it move around once you start. All right, so that's our template. Okay, so the first thing I'm going to do is make a line across. It's 2 inches in. And then 3 inches from either edge. That's where my leg should end up. I'm just doing the same thing down here, lining those up.